Hi, I'm Pete. I work on Dagster, and today I'm going to take you through a quick crash course for how to build an ETL pipeline with Dagster. This is a companion video to a blog post that we wrote. You can go check it out here to get some additional context and links to various documentation. If you want to just skip straight to the code, the completed code is available here at this GitHub repo. And finally, as we go along, I'm going to be using an in-browser editor called Gitpod and starting from scratch and then building it up from there. So you can just go here to get started with that. It's free and it makes getting spun up with a Python environment very easy. Just to set the context here, we're going to create this report and store it in GitHub Gist. This is going to be created from an IPython notebook, and it's going to visualize GitHub stars over time for the Dagster repo. So we're going to use the Dagster API, the GitHub API and Dagster software defined assets and the Jupyter API to do all this. So to get started, I've got this cloud development environment here. It's using a service called Gitpod. There's a link in the blog post. It's a free cloud development environment that guarantees a pretty stable and specific Python version. You can use whatever Python environment you want. Dagster works on Mac, Linux, and Windows. But I'm just going to use this for consistency. So the first thing we're going to do is pip install Dagster. This installs our command line tools that help you scaffold out a project. So we're just going to use the default simple project, but there are a number of different templates that you can use by accessing the help command. But I'm just going to say Dagster project scaffold, name my Dagster project. And you can see here that we've created a project in this workspace. So if I cd my Dagster project, I'm going to install the dependencies that this example project needs. So this is just how you do it. While it installs, I'll give you a little tour of what's in here. We have a little README describing the project, linking to the documentation. We've got our normal kind of Python setup.py where we list all the dependencies that we need. This workspace.yaml tells Dagster when we run it locally where to find the code. So Dagster looks for this workspace.yaml file to figure out what code to load. And then we've got my Dagster project, which contains the source code for our project. We'll be doing most of our work in there. And then we have the my Dagster project tests package, which contains all the unit tests for our project. So I'm going to start Dagster using this command dagit. There's actually two components to Dagster. There's the UI and then there's the daemon that runs the schedules. Because we're not going to be using schedules right now, I'm just going to launch the UI. And so you can see here that we've got this empty UI because we haven't done anything yet. But you just run that one command, dagit. It looks at that workspace.yaml file and it loads up your UI. So like I said, we are building that GitHub stars dashboard. So we need a number of dependencies in order to do that. So the way we add dependencies is it's like any other Python project. We just update this install requires part of the setup.py, and then we rerun the install steps, this pip install -e command. And so this is going to install PyGithub so we can access the GitHub API. It's going to install matplotlib, which will help us visualize what's going on with the GitHub stars. Pandas is our data frame, which is how we manipulate and transform the data. And then these four packages are what's needed in order to render a notebook. So the first thing we're going to do is we're going to want to fetch the raw data from GitHub. So this is going to create, basically the raw response from the GitHub API. So we're going to use software-defined assets to do that. We're going to use software-defined assets to begin to build our application. So I just copied and pasted this in before the cut. This is our example, software-defined asset for fetching the GitHub stargazers from the GitHub API. And so I'm going to actually put a real GitHub token in here. By the time you see this video, I'm going to have deleted it, so you can't use it for anything. Obviously, inlining a token or any sort of secret in your source code is a really bad idea. We will fix that by the end of this tutorial, but for now, we're just going to put that in there. And we're going to create what's called a software-defined asset. software-defined asset is a function that returns some data that represents an asset, a data asset in your graph. So this could be a machine learning model, a report, or a database table. In this case, we're just returning the response from the GitHub API. So we instantiate the Pi GitHub client, we pass it the access token, we do a little bit of function calls to get the stargazers with the dates. This is effectively like the username and then the date that they starred the repo, and the exact timestamp that they started the repo. And marking it with an @asset decorator indicates to Dagster that this is a software-defined asset. So the next thing we're going to need to do is, now that we have the raw API response from GitHub, we're going to need to transform that into week-by-week counts. So we need to go from these pairs of timestamps and usernames to the number of unique users that have starred the repo in a given week. And so I'm going to just paste some of this code in from the blog post. You can follow along with the blog post if you'd like. And so right here, I'll take you through how this works. Again, we have a second software-defined asset, which is called GitHub Stargazers by week. This takes a parameter here called GitHub Stargazers. What this actually is it's got a special name because it references this name right here. Now, Dagster, via the magic of software-defined assets and this asset decorator, knows how to match these two up. And so this basically declares a data dependency between the GitHub Stargazers by week and the GitHub Stargazers asset. What Dagster will do is it will know to materialize the GitHub Stargazers asset before materializing GitHub Stargazers by week. So now that we have that data, we iterate through it here, and we create a new data frame where we basically create one row for every user and when they start it, except we convert the timestamp from the exact timestamp to just the start of the week, and then we will aggregate by the start of the week. So you can see here, we call group by week, which aggregates everything into week by week aggregates. We call count, which counts within the week, and then we sort chronologically by the week. So then we get an ordered data frame, the start of the week, and then the number of users that started during that week. If you have questions about how this works, check out the pandas documentation. So the next thing we need to do is go from this data frame to some sort of visualization. Jupyter notebooks are a really common way to do it. Normally I would open up Jupyter to develop the notebook, but there's a little library that makes it easier. For example, it's called JupyText, where you can write a notebook just as a string of markdown inside of your project. So I'm gonna just paste in some additional code here. You can see we've added another software-defined asset called GitHub Stars Notebook. So this takes in GitHub Stargazers by week, which we defined up here. We create markdown representing the notebook. So you can just think of this as like an IPython notebook, like an IPYNB file, but just encoded as a markdown string using this library here. We convert it to an actual IPython notebook right here. We call this execute preprocessor.preprocess. This is something that we've imported from the Jupyter library, which will basically execute the notebook and put the results into it. And then finally, we call mbformat.write, which will write out the notebook as a string that can be read by Jupyter or any other service that supports notebooks. Finally, we want to take this notebook and upload it to GitHub as a gist, so we can take that URL and then share it with stakeholders. They can see the visualization. So let's go and do that. I'm going to just paste in the code here. So you can see here we've defined another software-defined asset with this asset decorator. GitHub Stars Notebook Gist. It takes in the GitHub Stars Notebook. This is, we don't need this right now. It takes in the GitHub Stars Notebook. It calls the GitHub API, tells it to create a gist, and then uploads the contents of that notebook as a file attached to the gist. And then we just log out the URL. And so we we've basically created all of our software-defined assets now. Let's try to take a look at them in the Dagster UI. So we've started up Dagit. Let's open it up. And now you can see our 4 assets that we created: the GitHub Stargazers by week, GitHub Stars notebook, and then the GitHub Stars notebook gist. So I can just click this Materialize All button, and you can see that we launched a run, and it'll go. So what this is doing right now is this is fetching all of the Stargazers from GitHub. This is actually quite a long operation because it is fetching all of the Stargazers from the beginning of time, which is a quite expensive operation. You have to do multiple calls to the GitHub API in order to do it. And as you can see, it takes a long time. One of the advantages to modeling your computation as a DAG of assets, the way that Dagster does, is that we can cache this computation and reuse it in the future. So for example, if we want to iterate on how the notebook works or how we're transforming the data, basically the core business logic, we don't have to do that fetch again. Dagster uses a system called I/O managers, and it stores that in persistent storage. In this case, it's stored on my local disk. But you know, in the future, you know, if you kind of go to production, you can use S3. It will be stored on you know, in a more kind of production ready blob store. So as you can see, I made an edit to my code, and I'm missing my context variable. So I'm going to add that back. So context is not the name of an asset. Context is actually kind of a special magic context that's passed through to every asset if it's asked for. So if your first argument of your asset is called context, you get this context object. It has a number of things on it, including this log function, or this logger, where you can call log.info. So as you can see, this failed because I introduced an error. What I can actually do here is just click on this, and I can re-execute the GitHub Stars notebook gist. So basically, I don't have to sit and wait for all of that fetching from the GitHub API. I can instead just run that one step, and it happens really quickly. So, you know, one of the things to take away from this here is that fixing bugs can be really fast when you model your computation this way. And so if I take a look here, I have a brand new visualization uploaded to GitHub. And I can go and share this with any of my stakeholders. Looks like the stars are going up. That's great. One thing to kind of note here that I didn't cover is how this notebook is created. We basically pickle the Stargazers data in order to get it in the notebook so the notebook can actually like visualize it. If you're using a different visualization tool, you might do it a different way. The last thing I want to show you is how to add a schedule. And so, you know, we basically have created a one-off job at this point. So effectively, you can go into Dagster, click on the launch run button or click on the materialize button and do a one-off run. But really, when you get to production, you want to, you really want to put things on a schedule. So I'll show you how to do that. We open up this repository here, and I'm going to make an edit here. So you can see that right now our repository, which is kind of Dagster's word for project in many ways, it just contains all the assets from our assets package. I'm going to put some additional things in here. We've got a define asset job function here. This defines what's called a Dagster job. So when we click that materialize button, that created what we call a job, and that job then materialized those assets, and we could run that job multiple times, and each one of those is called a run. So we basically say, hey, we want to have a job called daily refresh, and it will refresh all of the assets in the project. That's what this star means. And we will put it on a daily schedule. And then we simply add the job and the schedule to our project, and we can take a look at that in the Dagster UI. So I go to my workspace. I want to just reload all my schedules here. And then if I go to status and schedules, you can see here we've got a daily schedule, linked to the job, and the job, materializes all four of those assets. This warning over here, by the way, is because our daemon isn't running. Like I said earlier, there's the UI and then there's the daemon. These are the two big processes that you have to think about with Dagster. The daemon runs the schedules. I didn't start the daemon for this example. That's why we have that warning. All right, and there's a couple problems now with this project. Even though it works, we are able to build a full ETL pipeline from GitHub to a visualization and run it on a schedule. There's still some things we need to do before we can consider this project production ready. The biggest problem, I think, is this secret just sitting around in your source code. That's really bad. The second thing is we haven't written any tests. And the good news is Dagster is designed from the ground up to support really great testing as well as dealing with secrets. So in order to do that, we're going to use two Dagster concepts. The first one is called config, and the second one is called resources. So I'm going to create a file here called resources.py. It's going to contain our example resource. So a resource is basically, it's usually like a client that talks to an external system. So in our case, it's going to be our GitHub client. We're going to abstract that away into something called a resource. And what the resource lets us do is it can be configured separately from the rest of the application. And the assets will depend on the GitHub resource rather than the GitHub API itself. So we can specify, different access tokens to different assets. We can also swap it out and swap in a test double, for example. So when we write a test, we'll use the resource system in order to test without hitting the GitHub API. So just talking this through, we use the resource decorator to indicate that we've defined a resource. Technically, this is called a resource definition. The name of the definition is called GitHub API, and it simply returns a PyGitHub client that takes in the token that we are going to include in the config. We also need to give it a config schema. This can take regular Python types. So for example, I could just say, hey, this takes an access token as a string. But there's a super powered Dagster object called string source, which has some extra features, including reading values from the environment, reading from environment variables, which is very useful for secrets. So we're actually going to use string source here. Now that we've added the resource, or that we've created the resource, we have to actually add it to our project. So I'm going to go back into our repository. I'm going to import the resource. And then I'm going to add it to our project here. So the way that we do that is we use this function called with resources, which I will import up here. And we say with resources, and then that takes in definitions and then the resource definition. So the first thing we'll do is just pass in our assets. What this basically says is it'll give the resources to all of our assets in our project. And then we provide a resource name. So in this case, we're going to call it GitHub API, and then it's going to take in the GitHub API with a configuration. So the way that we do this is, this can be a little confusing. The GitHub API name here is the name of the resource definition. You can actually reuse that definition in multiple contexts in your application. And so there's a resource key, which is kind of like the instance of that resource. And so the way we create an instance of the resource is we call configured, which basically passes a configuration to it. This can also be provided as an external configuration file, but for this, we're going to include it in the code. And we can say access token, which was the name of the field in the config schema that we defined over here in resources. I'm going to show you this feature of string source now, where we can actually pass an object with the key of env and then the name of the environment variable. So what this has done is configured. Let me just make sure I mapped all my stuff correctly. I think I did. What this basically does is it creates a new GitHub client. It reads the secret or the token out of the environment, and then it gives that resource to all of our software-defined assets. So let me just reload the project and make sure that I didn't introduce any errors. Okay, that looks good. Up next, we have to actually use this resource from the assets themselves. And so if we go over here, we really use this GitHub client in two places. The first is in this GitHub Stargazers asset, and the second is in this GitHub Stars Notebook Gist asset. So one reads from GitHub, the other one writes to GitHub. And so right here, we provide required resource keys, which basically defines a dependency on that resource called GitHub API. And what this means is that the resource is now available to this asset, and we can get at it by just saying context.resources.github API and passing in or taking the context as a parameter. I had talked about this before. If your first argument to your asset is called context, you get a context object from Dagster. That includes things like the logger and also the resources. And let's make a similar refactor to this GitHub Stars Notebook Gist down here. We will say required resource keys, GitHub API, and then we will say context.resources.github API. By the way, other frameworks or technologies you may have worked with might call this dependency injection. It's a very similar concept. So let's actually test this here. Now we don't need this access token in our source anymore. We pass it as an environment variable, and then we'll run the UI. And if all goes well, I should be able to materialize all. And it looks like this is fetching all of the GitHub stars from the API. Now, because we've restarted the service and I'm using the developer mode, we lose our cache in between restarts of the Dagit service, but you can configure it with a custom, what we call IO manager, in order to persist that data somewhere in between restarts. So for example, S3. But as that runs, it's taking a long time, so I'm pretty sure that it's accessing the GitHub API correctly. So this is huge. We've basically just gotten rid of that secret from our source code, and we're reading it from the environment, and that can be provided using any sort of automation that you want. So the final thing that we need to do is we need to write some tests, and the resource system helps us write tests as well. So if I go over here and I open up the My Dagster project tests, I'm gonna shut down the UI because we don't need it anymore. I'm gonna open up this tests assets.py file, and I'm going to bring in some test code here. First thing I'm gonna do is bring in a bunch of imports. So I'm going to import the software-defined assets from our project. I'm going to import a Python utility called MagicMock that we're going to use a lot, a Dagster test utility called Materialize to Memory, and then some helper functions. So pandas to create data frames, and then datetime to help us create some test data. Then I'm going to create our smoke test. A smoke test is kind of like a really, not a super comprehensive test of every edge case. It's just testing the happy path and making sure that, the common case works. And we have a blog post coming out about this as well. So we're going to just simulate, 3 users starring this repo, 2 of them on the same day in January of 2021 and another one in February. Then we are going to create a mock GitHub API. So using the MagicMock library, we instantiate it, and then, I would definitely check out the documentation for MagicMock because it has some subtleties. Let me just make sure I've done this right. Oh yeah, okay, so that's correct. So just to hand wave over this a little bit, this mocks out this call from our asset that calls get stargazers with dates, and it mocks it out to return effectively this data set. So we're simulating that the GitHub API is going to return that data. Another thing we need to mock out is the write path. So we've mocked out the read path from GitHub, but let's also mock out the write path. And the reason we're mocking this out is so that our test can run and it's fast and it doesn't talk to any external service. And it also doesn't trigger any effects in the real world. So it doesn't, if you can imagine these APIs could cost money or have quotas associated with them. And you don't want your tests burning through that. So this mocks out, the create gist function to return a fixed URL and to not actually, upload a real gist. And then finally, we're going to actually materialize our assets in the test. So we have this function materialize to memory. We pass in the assets that we want to materialize, and we can also override, specific resources that we would like to use or provide them. So this is the resource key, and this is the resource definition. And then the last step is we want to actually write some assertions here, and I will paste these in. The first one just checks that there was actually a successful run and that the run didn't throw any errors. The second is we look at the output of the GitHub Stargazers by week asset. We do a little bit of pandas magic to compare it with the expected data. So if you look at our mock data set, we would expect 2 weeks of data, the first week in January to have 2 stars and the first week of February to have 1 star. We've got that here. And you can look at the original mock data if you don't believe me. Then we also want to assert that we have actually called that create gist function and that we are returning the URL correctly. So we do that here. And then finally, I added a little smoke test just to make sure that the GitHub stars notebook content, like the notebook file that was written out, contained data that we would expect to be there, and that the gist was created as a private gist, not a public gist. So if we want to run this test, we say pytest s my Dagster project tests. The -s is kind of running it in verbose mode, so we see all the log output and any print statements that we might put in there. And you can see here that our test passed in a pretty short amount of time. So it wasn't pulling all of that data from GitHub. It wasn't talking to any external system. It's basically just good old-fashioned in-memory testing. And it's always good practice to try to break your test and make sure that your test is actually testing something. So this is changing it to assert that we've actually made a public gist instead of a private gist. And you should be able to see that this test will break. Yep, it breaks. And then we can fix it again. So anyway, this was a crash course into building an ETL pipeline with Dagster. You learned a couple of things. You learned the primary way of development, which is using software-defined assets. You learned a little bit about how to use the user interface. You learned how to kind of migrate from a hello world to a more production-ready application through using the resource system, which lets you both unlock testability as well as unlock secrets management and configuration. But there's a lot more to learn, and so we have a lot of documentation, both linked from the blog post as well as additional tutorials and guides on our website. Please check it out, and if you like what you see, please star the repo. Thank you very much.